Hello, and once again, here we are with a webinar from Appvia. I'm Tennis Smith at the Appvia World Headquarters. It looks like I'm in jail. I'm not actually in jail. I'm in a room with a nice screen on it. And this is Salman, who's in sunny Cardiff. And you might want to introduce yourself, Salman, and talk about your background a little bit for those who are joining us for the first time and don't know much about either one of us, of course. And I'm Tennis Smith. I'm was a technical architect. Now I'm going to be pre-sales here at Appvia. I've been in the business a long time, too many years to count. I've been working with Kubernetes now for 3 or 4 years, and between the two of us, we've got quite a bit of experience with the technology. And we're here to talk about Kubernetes from 10,000 feet. In other words, just a brief overview of Kubernetes and what it is. And so, Salman, do you want to share your screen with the? Oh, yes, the housekeeping. Yes, yes. No, I can hear you just fine, Salman. Sure. Yeah, I hear you just fine, guy. Yes, sir. Yeah, we'll want to make sure that the audience can certainly understand us before we continue on. Yes, yes. Can somebody ask? I mean, excuse me. Can somebody post a question whether or not they can now hear Salman? I can hear him just fine, naturally, but it's more important that the audience can hear him. That's right. If you want, Salman, I can go ahead and yeah, yeah. What we're going to talk about is pretty much three areas. We're going to talk about the old classical way of doing things, which is monoliths, and the new paradigm, which is microservices, and that gives rise to the concept of containers. And oh, they're saying they still can't hear you yet, Salman. Huh. All right. Well, okay. Okay. All right. It's a yes. What we're going to talk about is, as I was saying, is initially the concept between a monolithic application and how that's done pre Kubernetes, then the concept of microservices, and then after that, the concept of a container and what it is, and then we'll talk about Kubernetes and how that is a technology that coordinates containers. And this is while Salman is rejoining. I'm afraid I don't have any graphics to show you, but if you think of it in these terms, that you have in the old days an application that had to have all of the uh, various and sundry uh, uh, reactions built into the application itself. When I say reactions, error recovery, networking, security, scalability, all of those things had to be programmed inside the application itself. So what you ended up with is a monolithic app that tried to do everything for all time and react to all situations. That's what I mean by reactive. Um, Along comes the concept of microservices, which is where you break down the large application into smaller components that would be networked together. And then you would be able to isolate your problems, excuse me, in such a way that it's no longer one giant code bed. You would have lots of little code beds. Um, the The problem, though, is that those little applications talking to each other through a network makes certain things more complex, like testing, for example. And we're going to go over that. Um, Again, I don't have the graphics at the moment, but hopefully you're following along with me. That gives rise to the concept of containers. And containers are a way to shrink wrap, so to speak, a very small piece of uh, well, shrink wrap only the things you need: the libraries, the file system, the utilities, and the application itself in one small entity that can be run in its own namespace inside uh, an operating system. And excuse me, and it's isolated from all the other containers running in the same operating system. And we'll talk about this a little bit more um, in much more detail with a graphic to give you a better idea. But the idea of a container is, as you, like I said, you have the shrink wrapped components and only what's needed to run. So if you think about it, when you run classically, when you run an application inside of a virtual machine or on your laptop or wherever, um, let's say, for example, you're running Microsoft Word. Um, you are actually only leveraging a small percentage of what's inside the operating system at any given time. You're using Word, you're using some subservient libraries, and you're using keyboard interrupt handling and that sort of thing. And that's about it. The rest of the operating system is sitting there, not exactly idle, but it's using unleveraged facilities. What a container does is a way to say, okay, I only want the application, I only want its subservient libraries, and I want them encapsulated into a single entity, and I want it saved off into what's called a container image. And then you run that image, and that image can converse with other containers, and they're standalone entities. So what you have is a collection of containers that are talking to each other. Well, here is the problem with that. The problem with that, the problem with that is the, uh, let's see, I'm just getting a message here. The problem with that is that you have to coordinate among those containers. And coordination among the containers is difficult. You need some overarching, there's Iqbal Salman, Mr. Iqbal. Sorry, sir.
Well, can we try to see if they can see? Can you hear me? Can you ask people if they can hear me now?
Yes, Salman has rejoined. Can people indicate whether or not they can hear him now?
Let's see. Let's see if that works. The slides, I've sent you the links to the slides, Tennis.
Oh, thank
the
you.
Slack. So if you can just open them up and share them.
Yes, sir. I shall.
Maybe Kirsten can. Let's see if people are messaging or not. Not yet. Here you are, Tennis. There's the slides for you. So maybe you can share them.
Yes, sir. I certainly will. All right. Now
people can hear me now. Oh, okay. Not sure what happened there, people. Apologies, but we're good to go. We are good to go. So,
okay.
Thank you very much. Not sure what happened there, but
Thank you, everyone. Yes, thank you very much.
Shall I start?
Yes, please go ahead. Yes, sir.
Let's go. Sorry about that.
No,
but,
that's all right.
We still gotta have fun. Go, Tennis. You continue. I'm not sure where you were.
Oh, I was just talking about. Well, first of all, we haven't talked about who Appvia is, and we are a company that offers an enabling technology for Kubernetes without going into great detail just yet. And we have technology that enables a lot of efficiencies. We're using things like multi-cloud. So go ahead to the next slide. Okay, so monoliths versus microservices. This is what I was alluding to before. Do you want to pick up on this one, Salman?
Absolutely, yeah. So, I mean, I'm sure we're all aware of what we're doing right now, which is we have, sometimes we just have one massive application or one big solution. Everything goes in that application. We've got the business logic, the UI, the API, the authentication. Every piece goes in that. And all the testing is written in that case. And then over time, we start to realize that there's perhaps not the best thing to do, because if I want to make changes to an application, one part of the application, maybe the UI, I have to release everything again. I have to regression test everything again. Becomes a bit of a problem. And then what we decided as technology, that maybe what we can do is probably break things up into smaller chunks, and they're independent of one another, so we can scale them separately, we can release them separately. The teams don't really have to rely on one another to say, we're releasing next week, can you make sure we haven't broken anything? So that's what the microservices architecture we're moving towards. Anything you want to add, Tennis, on that, or are we good?
No, just the main thing is that you went from one big application trying to do everything to lots of little applications that are cooperative amongst themselves. That leads to the Martin Fowler quote that it's an architectural style that is developing a suite of small services, and presumably they would be lightweight in character. The idea is that you would not have huge apps talking to each other. You want lots of little apps, just a few lines of code talking to each other.
Correct. And they talk to each other using REST requests, they're perhaps sending some REST requests and
Yes.
responses. I mean, we put some of this up. By the way, you will all receive the slides, so you don't have to frantically make notes about any of this stuff. This is just some discussion points between monoliths and microservices, as we were talking about previously, really briefly. If I have a monolith, I have to make sure if I make a change in one part of the application, we haven't broken anything else in the other part of the application. But in terms of microservices, pretty much every component is independent. As long as we don't break any of the contracts between the services, we're doing okay. So we can independently deploy them, update them, move a lot faster than we have to, because we don't really have to sync with the other teams to try and figure out, oh, should we release this? Should we release that? And should we release our features next week or whatever it might be? And I think one of the most important things, in my opinion, is that back in the day when I used to work in monoliths, if there was an issue in the backend service, let's say the backend logic, there was a problem with that, even the UI would stop working, right? Because everything is part of the same application. And then you can't really serve a reasonable error page to say, oh, please come back because we're having an error here or whatever it might be. So, failures can, if one part of the application goes down, it will definitely take out the other parts of the application because it is one bit. But in our case, in microservices, everything is self-contained, right? So if my backend fails, that's fine. The front end can still, give me a reasonable answer. Maybe if it's a bank application, the loan services failed, but accounts are still working, so that's fine. We can at least work in that way. And I think one of the last bits I would really say with the microservices architecture, we can have whatever framework we want to use. Let's say you say, oh, the front end is very good if I can write that in React. And let's say you might say, oh, I need to write some business logic, and that really works well with, I don't know, Go. Or if I've got something just, I need to do a bit of machine learning in some parts, oh, you can write that bit in Python. And that's absolutely fine because everything is separate. We do that with single development stack for monoliths. That was kind of hard to do. Anything you'd like to add, Dennis?
Yeah, it's just a really interesting aspect what you just brought up, which is, let's say that the UI was written with React, like you said, and next week we decide to write it in a completely different package. Well, we just have to modify that one microservice. Or the back end, for example, we used to be talking to MySQL. Now we're going to be talking to another database. That's one microservice that you change. And if assuming that the REST API conversations are honored in their contracts, the user doesn't know that, and you can just swap them out.
Absolutely. But it's not everything is rosy, right?
Yeah.
Tennis, because we've gone from monoliths to microservices, and there are some use cases in which a monolith might make sense. Of course, there's a tool for everything. But now we have a distributed system, which we didn't have before, right? We didn't have all these components that were perhaps deployed on different machines or working differently. So we've added a bit of extra complexity on top of what we were doing before. Because now I have to start to figure out, how do these communicate with one another? And when I'm doing some development, how do I test everything just to make sure everything works fine, And also, one of the things we put in here is crosscutting. This is all about, I've got all these different microservices. How do I collect the log from all these services? And more importantly, these services could be written in different programming languages. So if I collect logs, where do I get the libraries from? And how do I make sure everything's exactly the same? And also, if there's a circuit breaking or, fault tolerance, how do I do all of that? So we started to add challenges on top of what we had before. Tennis, would you like to add anything more?
No, sir. That's nothing for that.
Yeah, so I think there's patterns out there that help you with some of these challenges for microservices. And one of the patterns is the 12-factor apps. We're just going to put it out here. We're not going to go into too much detail about the 12-factor apps, but basically, we put 6, but there are 12. But these are things we can do to make our lives a bit easier when we're working with microservices. For example, number one code base many deploys. So you have one code base, you check all your code in, and you can, from that single code base, you can deploy multiple services, multiple microservices. You can deploy them in different environments, such and so on and so forth. The second one, which perhaps will become a bit more useful when we talk about containers, about declaring dependencies. I mean, there have been times where you're working on an application, and one person has developed this application, and they tell you, "Oh, can you try and test this on your laptop or on your machine?" And you try and run the application on your machine. It could be written in Java, could be written in Python, could be written in .NET, could be written in any language. And when you do that, things don't work. You test it out, and you're like, "Oh, things are not working. What's going on?" And then you realize they installed a dependency on their machine, which wasn't on your machine. So this is a bit about declaring dependency. It doesn't say how you declare the dependencies, but it just says you make sure you declare all the dependencies. And I think I'll add one more, and then we'll get Tennis to add his points as well. Like, one of the things that all of us try to strive is we need to make sure all environments are similar. Not the same, but at least similar. For example, the dev has to be similar to what the UAT should be, or what the production environment should be. And the only reason why we say they should be similar, or this 12-factor app says it should be similar, is because it's easier to replicate any issues that you might come across in production. If the dev is so far away from what production is, it's going to be hard to figure out what happens when the application actually lands in production. What we don't want is surprises. We want surprises in dev, I don't know, a SIT environment or UAT environment. We don't want any surprises in production environment. So that's why we want to keep them similar. Anything, Tennis?
Yeah, exactly. You strive to keep the environmental simplicity as generic, vanilla, however you want to put it, as possible. And to carry on with the list here, you want also your application to be stateless in character on the whole. Now, there's some exceptions to this, but for the most part, what you want is an application that does not have to have a lot of data retained to tell it what state it's supposed to be in when it comes up. That it just comes up and it reads from a queue, and then processes what it has. It doesn't have to read special databases and things like that. Also, which reminds me, the fifth point about configuration in the environment. What you want to do is to try to keep all your configs in environment variables that are passed at runtime to the app as it comes up. So that way you can change, let's say, how many threads you're running in a configuration statement without having to do stop and start and those kinds of things. And finally, you want a microservice to have fast startup and a graceful shutdown. In other words, you want it to be resilient in the sense that the application doesn't cause problems if you bring up new copies or if you shut down unneeded copies. I don't know, Salman, am I missing anything? Let's see.
No, absolutely. Yeah. So I think, I think there's more parts, but yeah, the fast startup is important as well, because let's say your application's running normally and you want to scale up from, I don't know, you got 5 replicas running and you want to go up to 100 replicas.
Yes.
And you want to do that really quickly. And that's why this fast startup is useful. And graceful shutdown is we just don't want to lose any traffic if something goes wrong, right? So that's what it is. We used to deploy our applications, we still are deploying sometimes our applications in virtual machines, and that's absolutely fine because we just need some resources to be able to run them. And the thing with virtual machines, the diagram you see on your left is in the virtual machine you have this technology called the hypervisor, which allows you to separate, which allows you to divide a server, an actual physical server, into multiple machines, multiple virtual machines. And that's absolutely great, right? Because I have a machine, I have one actual server, and I can make into smaller virtual machines, and I can give them to different teams, and they can do what they want to do with it. And there's good security isolation, because whatever happens in one virtual machine doesn't affect what happens in another virtual machine. It's like as if they are actual machines. But the only problem, we can't say the problem, the challenge is that when I have this virtual machine, each machine has to have its own operating system, or what we call it, in this case, we call it the guest operating system. That, you might say, that's fine, that's okay. And it seems like, okay, of course I need a bit of an operating system to be able to run it. But that takes about 10% of the resources sometimes on that virtual machine to be able to run just the operating system. And if you add that, imagine you have 100 virtual machines, and 10% of each of those, if you add it, that adds up to, I don't know, however much CPU or memory resources it is. That basically adds up to some resources that you are just using to run this guest operating system. On the other hand, we have the containers. And the containers say, you don't have to have this guest operating system. All you need to have is this container engine. Your Dockers or your Containerd, your runtimes. As long as you have that, you don't have to have the guest operating system. The container engine will take care of it, and whatever the host operating system is on that machine, it basically uses that in order to spin up your applications inside the container. Tennis, would you like to add anything on that?
Yeah, a couple of things. The diagram on the right alludes to what I was talking about before, which is shrink wrapping only those things you need to run a particular application, and you share actually the operating system kernel and can have apps 1 through 3 sitting there, and it's much more efficient than having an entire operating system as you have on the left just to run one application. So the benefits of the approach on the left is a much greater efficiency of operating system leveraging and a much more bounded collection of things that you have to manage in the form of that container, as I said, that shrink wrapped piece. So is there, excuse me, Simon, anything else you would add?
No, I think that's a good point. As we just talked about, there's some limitations because you have to use some of the resources for virtual machines, and I think one of the things that we haven't talked about is if I have a virtual machine in Azure, it doesn't work. The same virtual machine won't work in GCP, Google Cloud Platform, or AWS. You kind of have to recreate it. So basically, there's some limitations. There's some limitations for the application. But on containers, I don't know, Tennis, we want to talk about this slide here real quick.
Yeah, this is the process of containerization, and this slide is meant to depict the fact that you are taking only those little components that you need in order to run that one application, and you're extracting it from a larger context and saving it off as a container. It says the graphic says container, but it's technically container image, and that's the only thing that now you have to manage. So all the overhead of the operating system and the libraries and the maintenance that goes with the operating system, all that goes away.
Yeah, I mean, you still have to update the base operating system of a container when you need to. This is another depiction of the same thing. Usually, a container, you have some sort of a file system, and on that you do use an operating system of one kind
Well,
or
you
another.
use a piece of the operating system.
Piece of the operating system, not the full thing, the piece of the
Yeah.
operating system. And then you have a bit of storage, and all you do on top of it, you put all your files in and all your dependencies, and you package it all together into a container. And that becomes like, I don't know, sometimes this term container and image is used interchangeably. Image is basically a container that's not running, it's just there. And a container is basically a running image. But I think the takeaway for containers is a container is some sort of I think runtime is probably a better term to use than an operating system. Some sort of a runtime. Let's say you want to run a Java application, you have Java virtual machine, or let's say you want to run Python, you have Python runtime. Your application code, so all your code and stuff, all your configuration files, all your application files, and any of the dependencies that you are using, they're all defined and they're all included. And this goes back to the point that Tennis and I were making earlier on in this 12-factor app. One of the things, you have to declare your dependencies. And in order to create a container, you create it using this file, which is called a Docker file. Imagine if you're using Docker. And in there, it's just instructions of how to install your applications. And then basically we've got containers which are running. And I add some of the benefits we put on here. Depending on what kind of container you're using, it's quite lightweight. You can start it really quickly. You can stop it really quickly. There's no operating system we have to boot. It's just the runtime. And I think the most important bit is we've standardized the way we package and run software. So, for example, let's say if you want to run, I don't know, .NET application or a Go application on your laptop, you need to make sure all the frameworks are installed, all the things are installed correctly. But if I have a container, doesn't matter what the container is, I can just do Docker run, name of the image, and it will just run. So this standardization of packaging, and it'll run the container will run exactly the way it is running on my laptop, will run on the different server, will run on Tennis's machine, will run everywhere.
It'll run on Azure, it'll run on AWS.
Absolutely. You want to add anything, Tennis?
No, that's pretty much covers it, I think.
Yeah, and we can, if we are running containers, we can try and run multiple containers in a machine and basically try and save some of the resources. The containers are useful for reproducibility. We can take them and run them. There's some of these terms, the keywords that you might have come across before, like an image and a container. We talked about it really briefly. Image is just contents of a Docker container rest. All it includes is a runtime. It includes your files, all your files that you need to run your application, and any other dependencies. And then the container is when you start running the images container. By the way, if you have any questions, please feel free to use that ask a question tab and throw in. We'll try and answer them. Apart from that, you can't hear me, which was apologies for that, but I think we're good here. And then a couple of other keywords in terms of if someone talks about a container runtime or an engine, this is the bit that actually people use to start the container or stop the container or build it. And then if we have containers and images, we need to be able to share it with others. How do we share them? We use registries. Think of like the registries for your dependencies, where we store dependencies and stuff. And then usually we tag an image with a version of one sort or another. So some of the terms. But Tennis, do you want to ask this next question?
Yes. Containers are wonderful. But what happens when you have lots of containers and those containers are talking to each other, and some of them are coming up and some of them are dropping, and some of them need to talk to a container on another virtual machine? What do you do? And that's where, excuse me, that's where the concept of container coordination comes in. What happens when you have this situation where you have lots of containers and the need to coordinate among them and to scale them and to load balance them? This is where we introduce the Kubernetes. And Kubernetes is, as it says here, it's an open source system for, among other things, automating deployment, scaling, and management of containerized applications. And think of it as an overarching scaffolding for coordination among containers. And it's referred to sometimes as KATES, K followed by 8 and followed by the letter S, because it is K and 8 letters and S, just as an abbreviation. Anything you'd want to add, Salman?
Yeah, and I think it's important to also mention that these things are called container orchestrators, and Kubernetes is not the only one. There's a few more. There's HashiCorp Nomad, and I can't really think of others because I have them on the slide here.
No, there's Docker Swarm.
There's Docker Swarm, and there's some others, but we are focusing on Kubernetes because Kubernetes has taken the market share a lot more than the others, but that's what we're going to focus on. And yeah, these container orchestrators, for example, Kubernetes help with a lot of things. So you can see the market share for Kubernetes is a lot more than some of the other ones. We got Docker Compose, we got Mesos, and we've got some of the other ones as well. So this is why we are, Kubernetes seems to be like the container orchestrator of choice. And so what do you get with Kubernetes? One of the things that we we want to do with our applications is avoid downtime. Avoid
Mm.
downtime when something crashes, or avoid downtime even when we're doing updates. And this is where Kubernetes comes in. It helps us with, if you're doing new deployments, it helps us to make sure that we can do rolling updates. So we don't have to take the old one down until the next one is up. And that's where Kubernetes is very, very powerful in that sense, when rolling out new updates. If there's any breaking changes, there are techniques for that. But also, if one of your container crashes, one of the things that Tennis mentioned, what happens if the containers die? Well, I don't want to be woken up at 2 a.m. in the morning and logging into servers and starting and stopping the containers. And that's what Kubernetes does. It will go in and it'll start things up, what they're supposed to be running, because it knows the state of the cluster at all time, and it knows what the desired state of our applications in the cluster should be. It stores the information, and once that stores the information, it will always strive to go towards the desired state. And we'll look into that in more detail next week, of how it does it, what it does. And it's quite, that's how it does self-healing. And also, I'm gonna talk about scalability, and then Tennis is gonna talk about the bits at the bottom. I think that they'll kind of make sense in here.
Oh, yes.
In terms of scalability, what Kubernetes allows us to do is automatically not just scale the applications, also scale the cluster. If our cluster is too small, and we'll talk about what a cluster is, if we haven't got enough resources to run an application, what Kubernetes will do is it'll spin up more resources, spin up more virtual machines, and attach it to the cluster. Yeah, so tell us, what about the infrastructure abstraction and developer
Yes.
velocity? What do you think?
Yeah, the interesting thing about Kubernetes, well, let me start with developer velocity. Basically, if you have a Kubernetes infrastructure configured, you can turn around your application changes very quickly. So the developer doesn't have to have a lot of understanding about the infrastructure. They can have just a pipeline to install an app and update it as they need to, and can do that very rapidly. So you can deploy quite quickly on Kubernetes without having to worry about, uh, do I have to do something a little bit differently because I'm going to be bringing it up today versus tomorrow, and there's no issue with trying to make changes to the infrastructure. The infrastructure is just there, so the developer can concentrate on just developing the application. As far as infrastructure abstraction is concerned, what's interesting about Kubernetes is, properly implemented, Kubernetes running on Azure versus running on AWS versus running on GCP are all interchangeable in the way the applications developed for one would be interchangeable from the other, so that the Kubernetes environment is abstracted away from the hardware, and for that matter, the provider that's underneath. So as a consequence, you have a greater chance of portability. Now, you can always write applications to make them provider specific. I mean, you can always include certain things to make them provider specific. But if your goal is true portability, you can absolutely not have to worry about the infrastructure on which Kubernetes is running. It's its own ecosystem. If you write it for one kind of Kubernetes, it will run on Kubernetes on AWS just as well as Azure. Finally, Kubernetes is set up in such a way that it leverages the resources that it has very efficiently. It will not. It will use to the fullest the VMs that are associated with Kubernetes in such a way that you don't have to constantly try to play catch up with resizing your environment for Kubernetes. Now, long term, of course, you have to watch the metrics and that sort of thing. But my point is that the environment that you do have, it very efficiently leverages. Anything you'd want to add, Salman?
Yeah, no, absolutely. I think Tennis has mentioned all this stuff, and this infrastructure abstraction is something which is great, right? So a lot of times that people think about, we don't want to be tied into one cloud provider or another. Well, that's absolutely fine. Of course, this is something that everybody considers when they're working on the infrastructure. And that's the good thing about Kubernetes. If we write our applications for Kubernetes, we can run them anywhere. I can run it on my laptop, and I can run it on AWS. I can run it on GCP. I can run it on any of those cloud providers that allow me to run that, and those things don't change. So what does a Kubernetes cluster actually look like? Well, it looks kind of like this. Imagine you have machines, and they could be actual physical machines, they could be virtual machines, they could be Raspberry Pis, they could be anything. As long as they provide memory and resources, that's what a Kubernetes cluster requires. It needs some memory and resources. There's some minimum requirements how much memory they can have. And the way we set this up is we have a cluster, and the cluster it can include basically one or two things. It can include a control plane, which is the bit that's in charge, and we'll look into control plane next week as to how it does that. And then the other bit is the actual worker nodes, and the worker nodes are the bit where we actually deploy our containers. They get deployed into the worker nodes. And the point about a Kubernetes cluster is I can have as many worker nodes as I want. There are some restrictions in cloud providers. They might not, depending on the network setup, they might only allow you 200 machines in a node, but in a cluster, 200 machines in a cluster. But the point is you can have as many machines as you like. They can be of any size. They can be a GPU, it can be a CPU, it could be anything you like. And also, if you want it for resiliency, you can even have multiple control planes. And that's what AWS does by default. If you ask AWS to give you a Kubernetes cluster, it will actually spin you up 3 control planes, and each of them will be deployed in different availability zones. So if one availability zone goes down, you still have a control plane that's up and running. And this is basically what a cluster looks like. And every time we deploy our resources, we are communicating with the control plane, and we're saying, can you deploy this pod or this application or whatever it might be? And that takes our thing and actually deploys into the worker nodes. And we'll look into that next week. Is that anything else you want to add, Tennis?
No, well, a couple small things.
Yeah, go for
Just when you see on the left control plane, that's also a separate machine or machines, as Salman pointed out. So, and the graphic that we're using, which is the profile of a whale with the little boxes on top of it, that's the graphic for a Docker container. So if you're confused by that, basically think of that as just the whale with the little containers on it. That's just a Docker container. That's all. I just wanted to add that to make sure it was clear.
Yeah, no, absolutely. Thanks for clearing that up. Yeah, it's just running containers. Right. So a couple of things. What are the features? I think so. This is one of the last things we'll discuss in terms of what we're going to be talking about. What does Kubernetes help us with? And then, if you have any questions, feel free to ask us. I think the important also thing, the second part of this is next week. So definitely do dial in next week, and we'll show you how you can deploy your applications in your Kubernetes cluster and explain some of the other concepts that are in Kubernetes cluster. So one of the things that we have to do if you don't have an automated container orchestrator is for us to log into machines and say, I'm going to deploy this application in this machine, I'm going to deploy my database in that machine, and this application in that machine. But with Kubernetes says you don't have to worry about that. You just give me the container and I will decide where it gets placed. So it does automated scheduling, and it does that based on what your requirements for the application are, and it's quite smart. For example, if you have multiple replicas of an application that needs to be deployed in the cluster, it won't take all of them and deploy it on the same worker node, because if that worker node goes down, we've lost the application. So it will do it and start distributing the workload. It will deploy one of them in the first node, maybe another one in the second node. And what it'll try and do is, based on what your requirements for the application are, the CPU and memory requirement, it will try and pack it as close as possible to make sure your virtual machine utilization or your machine utilization is high. You're not losing out on much. That's what the automated scheduling is. It's quite advanced in the sense that you can customize it too. And one of the things that Kubernetes also helps with is that the concept that we talked about earlier on, if anytime my application crashes, it can bring it up without any issues. And then before Tennis talks about auto-scaling, I'm just going to mention this automated deployment. In Kubernetes, you can deploy your applications as part of what's known as a deployment, which we'll talk about next week. And deployment is just a recipe of what your application looks like, how many replicas it wants to run, what container it's running, what are the environment variables it needs to use. And if I say I need to have 3 replicas running at all times, and one of them goes down, it will bring it back up. And also, I can make releases in an automated fashion. I can do a rolling update. So if I'm going from version 1 to version 2, what Kubernetes does is brings up version 2 first, and then it says, yeah, everything's looking good. Some people start going to version 2, and it'll start killing some of the pods from version 1, just so you don't have any downtime. And there's other different types of deployments as well. You can do a green-blue deployment. You can do a canary deployment. And in a canary deployment, you send some traffic to the older application and some traffic to the newer application. See how everybody's doing it. Are we getting any errors? And if you're all happy, you can switch over all the traffic to the new application. And in a green-blue deployment, we basically can have 2 applications running at one time. And if there's a breaking change and we want to switch from one to the other, we can switch them really quickly. What about auto-scaling, Tennis?
Autoscaling is a really interesting aspect of Kubernetes. You can define how many minimum and maximum copies of a given, well, I'll say container. It's actually a pod, but let's say container for the sake of argument. How many copies of a given application can be running at any given time? And when there is traffic to justify it, make new copies to accommodate that. So let's say you're running with a minimum of 2 copies of an application, and then suddenly there's a lot of traffic coming in. You can auto scale that, or you can arrange Kubernetes to that, and then auto scale automatically to say 10 copies. And then when the traffic volume drops down, it goes back to 2 copies. So that's a very powerful feature that, once again, like Salman was saying, you don't have to get up at 2 in the morning to bring up new copies just to accommodate new traffic. Kubernetes has the hooks such that it will accommodate that for you. And that leads to load balancing, which is a high availability feature, so that you can take your traffic and judiciously balance it across different applications, so you don't overrun one application and you can have 3 or 4 different things accepting data at the same time, and therefore balancing all the work across different worker nodes, if you like. And excuse me. And we talked about infrastructure abstraction before. I don't know that there's really very much to add to that, other than to say that you can have a generic environment, and that it as long as it's designed to work in Kubernetes, it can work in Kubernetes anywhere. And just like Salman said, it can work just as easily on a Raspberry Pi as it would on AWS. Anything you would add to that, Salman?
Yeah, I think like in terms of auto-scaling, you mentioned about the application auto-scaling, also cluster auto-scaling. We have mentioned it before. We can define metrics to say if an application, if a container takes like longer than 2 seconds to respond, scale up, and that's how we can do the scaling up. So that's what the different features of Kubernetes are. And be sure to join us next week in terms of we're going to dive in a little bit more detail of what all of this is. So I think a bit of a summary. As we said, we've been talking about today about how containers can help with microservices. We can microservices produce a lot of challenges, and we want to be able to run all of these things together and orchestrate them and start them and stop them. We can stick them in containers to make sure we can run them always without any issues, and we can run them in different environments. And then we talk about how you have containers, and managing multiple containers is a bit of a problem in terms of if all of them go down, how do we bring them back up? And what about if something happens to a machine so a container is running in one machine, it needs to talk to a container that's running in another machine. How do we do that communication? That's where Kubernetes helps. And we'll talk about a number of Kubernetes benefits, which was different things in terms of auto scaling, auto scheduling, and self recovery where anything goes bad. You can start the containers, and also in terms of what happens if we want to do a deployment without any downtime.
We've
This is where
got
Kubernetes to help with. Go on.
we've got a question come in. Actually, a few questions.
Okay.
And I'll read them out, and then we can
Yeah.
take them on a moment. How easy is it to implement this on a small scale? For learning purposes, they're asking. And what
Okay.
kind of applications would you recommend deploying to them to learn how to work with Kubernetes? So that's not all, but we can start with that. You can deploy Kubernetes on your laptop. If you would like, you can also deploy Kubernetes on Raspberry Pis. There's MiniCube runs on your laptop. Is a wonderful learning tool. So there are several out there. If you go to excuse me.
If you want to do for like learning purposes, I highly recommend this MiniCube. If you just like make a note of that MiniCube stuff, you can go on there, or you can do a kind. And what MiniCube does is basically spins you a virtual machine. That virtual machine, just one node is your control plane, and it's your working node, and everything gets deployed on there. And kind is Kubernetes in Docker. It actually spins up Kubernetes inside Docker. So you can definitely use this on a small scale and run them there. And now, what kind of applications you should deploy if you want to learn? I'm just going to give a shout out to Katacoda. Just make a note of this stuff. This Katacoda is a great platform, by the way. If you're doing it for learning purposes, it will spin you up a Kubernetes cluster inside a browser. Well, it actually spins up in a virtual machine that you don't see, but there's Kubernetes introduction courses. You can go in here and you can start up. It launches a MiniCube cluster in the browser for you, so you don't have to launch it. But definitely give a look. Try these, because there's examples in here that helps you to deploy stuff.
Okay, and
I think there's another one. I'm gonna let me quickly find that. But I'll share it in a second as well. God, you want to add anything else?
Yeah, the next question was, how does K8s and K3s differ? And K3s comes from Rancher, and I think that's mostly meant for IoT. It's a lightweight Kubernetes that is primarily. I mean, is there anything you would add with that?
I think So the only as Tennis says, they're basically supposed to do the same thing. The only thing is that K3s is just a single binary. It's like a lightweight Kubernetes distribution. It's a Kubernetes distribution, which is a bit more lightweight, and it's a single binary, which is like less than 40 megabytes, and it completely implements the Kubernetes API. So, but what it doesn't have is a lot of add-ons that you have to perhaps add them yourself. So some things in K3s don't exist, but you're more than welcome to try things in K3s or K8s, whatever is easier for you. Of course, there's more like information out. Whatever you run in K8s or K3s will also run in K8s. So I think that's absolutely fine. That's no issues whatsoever. I'm gonna add one more thing. So we also have some exercises for Kubernetes in GitHub, which I will share a link to, that you can definitely try on. But while I'm looking for it, you just have to give me a second.
No problem.
I'm looking for it in the GitHub. I should have had it handy.
That's all right. And one follow-up question was, how applicable are the skill sets learned by deploying one or the other or to the other? And the short answer from to echo what Salman was saying is they are very applicable. So if you become very skilled with K3s, you shouldn't have any problems going to K8s. would start with something like MiniCube or Raspberry Pi or something like that, especially MiniCube, because it's so easy to do these days.
Yeah, definitely. If you don't want to, definitely start with MiniCube. There's examples out there. So many things that you can try and find out, and we'll also release some stuff. Watch out. Our blog. So we have a blog as well. If I head over to appvia.io, if there's some stuff you want to blog. If you want to learn a little bit more about Kubernetes, we have tons of blogs, and I think we are also gonna put out another blog about getting started with Kubernetes and what kind of things you should look out on. So we're gonna stick it here. So just keep an eye on this page, and there's going to be a blog out quite soon. So that's that. There's a couple of things. If you are interested if you are using Kubernetes, and Kubernetes is very complex in order to manage. Hopefully we answered your questions, by the way. If you have any more questions, that was a good question. If you have any more questions, please feel free to ask. One of the things that Kubernetes is, the problem with Kubernetes is kind of hard to manage and deploy and get it up and running. Getting up and running is kind of easy, but doing it properly, make sure it's secure and all that's kind of hard. But we have a tool called Wayfinder in Appvia. Check it out. If you're interested, just head over to appvia.io/wayfinder-trial. Just head over to the website. You can find it. It's a cool tool. It helps you ease a bit of a Kubernetes pain when you're getting started. Anything else you'd like to add, Tennis, on that?
No, not really. It's just that it really eases the pain of implementing Kubernetes to begin with, so you can get in and start developing applications quickly.
Yeah, absolutely. That's right. And I think I'm going to add a couple more things in here. Please do join next week if you want to learn a little bit more about how we deploy applications. The person who asked that question, we will be deploying applications next week. We're going to be doing that together. We'll be sharing some resources, and Tennis and I will actually be there in person. We're going to be doing that.
Yes.
I know this is the first time ever we'll do this. We'll be there together, sitting in one room and talking to you about this stuff. Hopefully you will find that useful. So please do sign up for the next one, which is on next Thursday, 16th of December, same time as it is right now. If you have any questions, feel free to ask us. I'm going to end my screen here so you can see us, just so we can show you that we're actually real human beings and not just some pods running inside a Kubernetes cluster. If you have any questions about anything, feel free to ask us, and do check out our website, appvia.io. We've got some useful blogs, and we have a new release of a product out which helps with Kubernetes. So anything else, Tennis?
No, sir. And so far, no questions. So
yes. Thank you very much for everyone for joining in. We really appreciate that you taking time out and joining us. And please do join us for the next one.
All right. Thank you
all.